Okay, so thank you very much for your time to be here. And I'm Kentaro Sano with RIKEN Center for Computational Science, R-CCS. And so originally, the division director, Masaaki Kondo, was scheduled to chair this session and give a talk here. But now he's not available to come due to some other commitments. So then I took over his duty here. So in this session, we have 3 talks, including mine. And I would like to take 15 minutes to explain the overview and current status of the FugakuNEXT project. But in this session, we also have 2 other talks given by those speakers. So Yoshihiro Kusano-san with Fujitsu Limited, and Dan Ernst with NVIDIA, who are going to talk about their technology development for FugakuNEXT. So I hope you are looking forward to them. Yeah. So let me start with the FugakuNEXT development strategy for enhancing scientific and industrial competitiveness. So today, we have those 3 strategic elements. The first one is the concept of made with Japan. So as the director, Matsuko-sensei, explained, we are having it for this project. Today, it's increasingly difficult to build a large and complex HPC systems only within a single country, as the relevant industries and supply chains span the globe. So we are building competitive systems and advancing domestic technologies through global collaboration, driving market expansion in Japan's semiconductor industry. So we are also developing talent through international collaboration for ensuring sovereignty in IT technologies. The second element is the technological innovation. So we are driving collaborative development of tightly integrated high-performance CPU, GPU architectures, advanced memory technologies, and so on. And we are also driving AI and HPC innovation for up to 100x application performance gains. Yes, I will talk about this in more detail later. The third one element is sustainability and continuity in technology advancement, development. So we are building ecosystem-ready systems with sustained software development. And we are also modernizing applications for future advanced systems and establishing the supporting framework. So we are also considering achieving energy efficiency by advancing operational technologies. So as a result of those strategic elements, we are aiming at FugakuNEXT ecosystem to strengthen Japan's semiconductor and IT infrastructure. And as a result, we are expecting to expand computational frontiers through the development of next-generation AI, HPC platforms, and advancing science with AI for science. We are also aiming at ensuring Japan's sovereignty in advanced AI technologies and computing infrastructure. So we are also considering the sustained R&D through continuous semiconductor innovation and secure computing resources in Japan. This is our strategy. Especially in the Made with Japan development framework, we are designing a world-leading system with cutting-edge technologies. And to this end, so we are collaborating with Fujitsu Corporation, which is a global leader in high-performance ARM-based CPUs, who is developing the next-generation CPU. So probably Kusano-san will explain this in more detail later. So we are also collaborating with NVIDIA for joint development, which holds the world-leading GPUs and their development environment for AI and HPC. So we are also collaborating closely with other relevant vendors and academic institutes in Japan and in the world. Additionally, we also have a collaborative relationship established. So today, four-way MOU among Algon National Laboratory, Fujitsu Corporation, NVIDIA, and RIKEN was signed to advance AI and HPC. So those framework allows us to advance globally compelling technologies by leveraging each party's strengths, designing a global standard system in the era of AI HPC convergence. So this is a press release website and papers of our press conference held in the last April. So RIKEN announced the launch of the internationally coordinated development of FugakuNEXT with Fujitsu and NVIDIA in the last August. And this has been positively received by many media in Japan. And as shown here, we have more than 46 newspaper articles and television introductions and so on. So FugakuNEXT was very, very attractive and very had big focus in Japan, I think. So next, so I'd like to talk about the more technical details about FugakuNEXT project and system. And this slide shows the targeted performance of FugakuNEXT. So first of all, we had the performance targets by next HPCI, High Performance Computing Infrastructure Plan and Promotion Committee, like this, as a target for the next generation flagship supercomputer in Japan development. So we should have 5 to 10x higher effective performance than Fugaku for existing HPC applications. The second is 50 exaflops or higher for effective AI application performance with Z-scale peak performance in mind. So in this sense, we think we can call this system first Z-scale computer, especially for AI capability. And so then as a third target, the overall application speed up of several tens of times of combining simulation and AI. So based on this proposal or recommendation by the committee, and so we had this performance target for especially basic system design procurement for vendor procurement. So in this table, we have several columns, and this is FugakuNEXT performance target numbers for CPUs and for GPUs. And here we have performance numbers of Fugaku system, present flagship supercomputer in Japan. And this is relative improvement. And for double precision FP64 vector performance, which is required for HPC, general HPC applications, we are aiming at more than 5.7x performance. Okay? For AI performance, computing performance with, for example, FP16, half precision floating point matrix computation, or FP8 matrix, or sparsity utilized FP8 matrix, we are aiming at 150 exaflops, 300 exaflops, or more than 6 exaflops finally for sparsity considered FP8 matrix computation, which is not seen in the case of FugakuNEXT system. For main memory capacity, and CPU and GPU each has more than 10 petabyte capacity each. Yeah. So which is for more than 4 times larger than Fugaku main memory capacity in the total entire system. And for main memory bandwidth, so CPU is expected to have more than 7 petabytes per second throughput in total, and GPUs are expected to have more than 800 petabytes per second, which is especially for GPUs higher than 5 times higher than Fugaku system's system memory bandwidth. For those performance targets, we are aiming at to use just 40 megawatts or less, compared with 30 megawatts maximum power consumption in the Fugaku system. So in this sense, we don't increase the system power a lot, but we increase the system performance, yeah, more than the improvement ratio of power consumption. So I mentioned that we are targeting 100x application performance gain, but as I also shown, the system hardware cannot bring 100x computational performance improvement. So how we should do this, achieve this? So this slide shows that. So here we have K computer and its application, HPC application performance, hardware performance for HPC applications in double precision, and software performance, and AI hardware performance. Yeah. So for software performance, we use the K computer performance as baseline with 1. Okay. So finally, we are looking at in total up to 100% speed up, shown here. Yes, from Fugaku ones. And by hardware, we are expecting more than or up to 6 times higher performance by depending on relying on only hardware improvement. But we also make up to 20x application improvement by optimizing, by advancing, updating schemes, algorithms of applications. And also, we are trying to utilize AIs to be integrated in applications. So we can expect some combination or integration of AI-assisted performance improvement together with application improvement and hardware improvements to make 100%, 100x application effective improvement, yes, in total. So this is what we are thinking now. So unfortunately, my time is quite limited, and let me go quickly through the remaining pages. But this is the overview of FugakuNEXT architecture. So where we have a compute node with Monaka X CPUs developed by Fujitsu Corporation, connected with NVIDIA cutting-edge state-of-the-art GPUs developed by NVIDIA. And those GPUs are connected with scale-up network. And the entire system is also composed of many compute nodes with scale-out network. And so we are considering several specific technologies to advance this system. So one is Monaka X CPU itself. It's a ARM-based many-core CPU. And we are expecting to have NPU, Neural Processing Unit, based on ARM SME. And for CPU-GPU connection, we are considering adoption of high bandwidth coherent CPU-GPU interconnect. And for NVIDIA GPUs, we are considering high performance vector and matrix units, of course, together with consideration of some kind of advanced memory in the future available at that time. And for scale-up network, we will have consider the multi-GPU interconnect via NVLink, either within a node or across nodes. So this is what we're thinking. But target architecture configuration will be determined in the basic design phase that we are conducting right now. So co-design is also important, and we are also conducting co-design and ecosystem building based on this strategy. For co-design, we are collaborating with application groups. So to co-design with a wide range of applications, not a limited small set of applications. Sorry, excuse me. And for that, we are having benchmarking system or platform for wide variety of applications with continuous verification through continuous integration, continuous deployment, and continuous benchmarking framework. Yes, so for AI-driven application development and coding optimization, we are planning to adopt vibe coding and a tool developed by Katagiri Sensei, what he explained in the previous session today, and to have higher productivity in application programming and system software development. And we are also procuring FugakuNEXT test beds by deploying proxy machines for FugakuNEXT with state-of-the-art GPUs available in advance has similar architecture and candidate technologies to the FugakuNEXT ones. We are also leveraging new GPU machines installed in R-CCS and other supercomputers. And we are broadening our user base because the community is very important for us to leverage our development and application and system software advancement. So I think time is up, and I need to skip the remaining slides. But finally, let me explain this timeline of FugakuNEXT R&D. So we are scheduling to start its operation around 2030 in about 4 years, 5 years. Yes. So now we are in the almost the end of basic system design phase conducted in this fiscal year in Japan. And from the next fiscal year, we are starting the detailed design phase for 2.5, 3, or 3 years together with the vendors. So I'm expecting all of you here to look forward to our system design and application performance projection estimation. Yeah. And I'd like to have this journey together with you here, so to see the future together. So that's my talk. Thank you very much.